Great, thank you, Andrew. Yeah, we've definitely got some time for questions. Liz from USGBC does have to hop off a little bit early, so we're going to take lead questions first. So get those in, and as those questions are coming in, real quick, for those of you who want to get your CEUs, if you're watching this live today, take that survey that pops up. Same survey sent to you in an email an hour later. Just take it once, and we appreciate that. For those of you in the future watching this on demand as a recording, take that 80% quiz, or take that quiz with an 80% passing rate, and then from there follow the instructions of how to snag your CEU from that. And for those of you on YouTube watching this in the future, again, go down and click that YouTube link. And then when you click that, up will pop some more information down at the bottom. Click the Show More tab on the left there, and then on the right, you'll see a link to access the quiz and then submit that. And then real quick, as those questions are coming in, just a huge thanks to all of our sponsors, our top sponsors, Shrinergy, Panasonic, T-Stud, and Mitsubishi Electric, and all of our other sponsors, our members, our board of directors, and all of you for helping us do what we do and get the word out. And so with that, let's dive into some questions here. And again, I'm going to just kind of get to some of those lead questions first, just so we can make sure Liz gets those answered. You know, the one specific one that I see here, Liz, is really more of a general question I think could apply to everybody, but I know they specifically focused it towards you. But maybe everyone can answer that. And I guess what I want to say is, you know, because a lot of these projects range from all the way down to what I would say is an existing small home renovation up to, as Andrew just showed us, a skyscraper, you know, how can soft costs for fees, you know, be aligned so it's affordable? And what would those be for, you know, small single family projects? And Liz, I'll kind of let you take that first, and if anybody else wants to answer, we can go down the line.
Sure. So for single family projects, just to clarify, we are developing, we're going to be developing a specific LEED Zero program for single family. So that isn't something that we have right now. And we'll be looking at the fees when we do that. We have tried to keep the LEED Zero fees small. They're really just two categories based on size of the building, and they're pretty modest. There's no registration fee at all, so it's only at certification. So if there is a single family project that wants to start exploring that, we'd love to talk to you and see and help inform our decision making as we work on that program.
And Liz, real quick, is it fair to say that the project though does have to be LEED certified first under one of the various rating systems?
Yes, so either LEED certification or currently registered for existing building operation maintenance.
And I guess just on the topic of fees, does anybody else, you know, want to speak to some of just the general soft costs for the program?
Sure. This is Lisa.
I'll chime in. This is.
Oh, sorry. Go ahead.
Yeah, mine's quick. I was just going to say that the Zero Energy Ready Home program is really structured around minimal fees because by building on the existing HERS verification process, more and more being used for code verification, the incremental verification costs can dwindle down to a very small amount, and there's no certification fees for any of the federal labeling programs from Energy Star to Zero Ready Home to WaterSense and Air Plus. So there's no certification fee, and if you're using a HERS rating to do your code compliance, you'll find that your verification costs are also minimal as well. So it's really used by leveraging the existing infrastructure that's out there in the market, you can really start minimizing those soft costs for the builder.
Yep. And then just to build on that, PHIUS has, I guess, two fees, one toward PHIUS, which is the design review for a single family home. That's about $1,500. And that's, you know, reviewing an energy model, working with the submitter and helping through the design. And then there's the cost of paying the third-party rater, which Sam was just describing. So there's a little bit more you do over Zero Energy Ready Home in terms of on-site testing, but not a significant amount. So that fee goes elsewhere to the third party, and then there's just the single fee to PHIUS around $1,500.
And this is Andrew Lee with IFI. For single family projects, our certification fees for both zero energy and zero carbon are $1,250, so $1,250, and that includes all the auditing associated with that project. So you don't need to pay any additional fees for third-party auditors. That's included.
Thank you. So another question, and this might be, maybe for everybody, but specifically Liz and then Andrew. And the question is, going beyond net zero, having programs for that, and considering that in regards to, being able to charge transportation devices through renewable energies with the project.
So the question there is that a two-part question, like net positive?
Well, yeah.
And also
it came in as a statement, so I tried my best, but I think the question is net positive considered as a certification in the context, and how does that relate to transportation?
So this is Liz. I can quickly jump in there. So for LEED Zero Carbon, we are looking to account for all the various ways that the building operations and the way its occupants use the building and get there are accounted for in the carbon balance. So we are including the carbon impact of transportation, like commuting or a fleet. So that regard, if you are doing electric vehicles that are charged by renewable energy, then that really helps your balance because you'd have a lower carbon footprint for that commuting part of your calculation. And the LEED Zero Energy side of things, if you are doing electric vehicle charging, we are not counting that as part of the building operations. So that, because that program is focused on really building energy use directly. So that is not including energy, and you could subtract any EV charging.
Yeah, this is Andrew with ILFI. Likewise, we exclude electric vehicle charging from our energy balance that we measure in zero energy and zero carbon. And related to net positive, I actually didn't share some of our other programs that are housed within the Living Building Challenge. Any projects going through that program would be measured against a net positive target of at least 105% energy production, as well as some energy resilience requirements. So definitely take a look at Living Building Challenge. Those are some of the world's leading projects that are truly defining that regenerative vision.
Oh, Andrew, on that note, is it the way I read it, either both for the Zero Energy Pedal, if that still exists, and Living Building, is that you technically need to be you need to have uptime during grid outages. Is that correct?
Yeah, it includes a battery backup requirement that's essentially, providing a basically critical load resilience for a period of a week. And
is there still the energy pedal too for that?
That is within the energy pedal.
Great. And then, Lisa, Sam, you can chime in, but is it fair to say that DOE's Energy Ready and Passive House really have no connection to transportation, correct?
Yeah, for
For me, yes.
Oh, go ahead.
Go ahead.
For PHIUS, it would not be included in your Source Zero certification. You could, but it's not required. Your vehicle charging.
And I'll echo that we have zero involvement with the transportation side of the equation. It's a builder program, it's a builder certification, so it's purely about the home. So definitely not Now, there's DOE, there's transportation offices that have programs and other things going on. So we stay focused on our core competency.
Yeah,
Great.
and Brett, this is Andrew. If I'll just add one more thing. Actually, when we some of our recent Living Building Challenge projects that are doing the battery backup, the resiliency aspect of Energy Pedal, they are actually looking at integrating EVs as their source of backup power. Because we do think that there is a real opportunity in the future to have an integrated transportation and building sector when it comes to managing renewable energy resources. So we certainly encourage that to be used for the resilience aspect of those electric vehicles, but we don't certainly penalize its use under the energy budget.
And to clarify that those backup and critical loads is not a part of your standard net zero certification though, or carbon.
That is not part of zero energy, correct. Yeah, for zero energy, we just look at creating a zero energy balance.
Okay.
One more chime in. You brought up the battery. The battery is considered under some PHIUS certification, but not for zero backup battery of any sort.
Well, that's a great question, Lisa. I mean, if you're pulling from a battery, do you have it in your calculations that is that part of the calculations that you're putting together to try to figure out how much site solar you need or how much off-site solar you need? Does the battery influence those calculations at all?
Yeah, so batteries are included in the PHIUS core certification, where you can only offset or meet a certain source energy target with a portion of the renewable energy you generate. It's a coincident fraction of production and use. So however much you're using while you're actually generating it. So it's generally about a third if you're at site net zero. But if you have a battery, that coincident production and use increases, you're actually able to offset more of the use in the building with your array than that maybe third or 30%. Maybe up to 40%, something around that range. So it's factored into the offset to meet a specific target, but it doesn't change the size of the PV array you would need to get to zero.
And Liz, that if you're still with us, if you have a second, that makes me think about from what I've seen on LEED Zero, where sending renewable to the grid is essentially more rewarding than using it on site. So in that case, does the battery in that equation change anything?
I'm not sure about what you said there, but I mean, I think with LEED Zero Carbon, if you have a battery on site along with renewable energy generation on site, then you can definitely reduce your draw off the grid when the grid is at its peak carbon emission levels. And if anyone doesn't know about the variation from hour to hour, even like minute to minute, there's a number of websites that illustrate this well. There's Watt Time, I think it's .org, that's RMI organization, and also electricitymap.org, and it's pretty fascinating to look at that. But basically, if you can adjust when your peak demand is, that can have a big impact on your overall carbon footprint from your power use. So that's, I guess, the main role of batteries that I would see.
I'm really glad you said that because, in the last, maybe a couple of weeks, I have started to notice that, maybe this is really the next direction for net zero, in that what we really want to do is sort of reduce those sort of peak loads so that utilities don't have to have these large dirty plants to just manage it. Does it seem to be that we might be headed in that direction with these types of programs where that's really going to be the focus? And this is sort of a question to everybody.
This is Liz again. I mean, we're definitely seeing that this recognition that buildings can be better grid citizens. And we've been working with NBI on some metrics that would help recognize that under this Grid Optimal program. There's also folks like the National Association of State Energy Offices that is looking at how to better promote buildings that work with the grid and help in this transition, because the more energy demand there will be from electric vehicles, then we have to moderate that and be able to handle that on the transmission and distribution system. So so there's a lot more that we can do with buildings, dampening those peaks along with high efficiency and on-site renewables, I think is going to be where we're heading. Sorry, Lisa, you were going to add something.
No, that's okay. This is Lisa with PHIUS. I wouldn't say that our specific certification programs we have right now actually acknowledge that or lead it in the right direction, but do lead it in the right direction. We're kind of trying to make the case that passive buildings actually have the ability to shave these peak loads. You don't need to come home from work and turn on your cooling system and blast it in the middle of summer. You can, do that at 2 or 3 p.m. when the grid is loaded with PV, and actually have the, you can actually utilize your PV and then shave off your peaks. So just inherently with passive building, we believe that it can shave those peak loads. It's just a matter of having the technology and the, knowledge to do that, and knowing, informing the tenant and informing the occupant.
Great, thanks. I didn't know if Sam or Andrew, if you had any other comments on that.
I was just going to say that peak reductions just come along for the ride. The optimization and reduction of heating and cooling loads is just inherent with, I think, all these programs. So but probably the big difference maybe for us, it will be the reduced focus on on-site solar. Just from a pure societal perspective, you only get about less than 50 cents on a dollar for a rooftop or building top system versus a distributed generation, utility scale, and microgrid system. It has to do with maintenance, optimal orientation, and less cooling, less heat behind the panels. And then also with the rooftop systems, you lose tremendous other benefits that can be added to the value of solar systems. Distributed generation systems, bar control, frequency control, transmission line constraints can be managed, and that can more than double or triple the value of each kilowatt hour. Or you can just do basic things like put PV, microgrid systems, or distributed generation on parking lots in hot climates, and just the shade for parked cars will increase the value of the shopping center. So it's kind of from our perspective, we're not prioritizing rooftop systems, which is why we're zero ready, and let the grid and other players figure out how to do that over time. Right now, the PV systems are exacerbating the duck curve in California and other places where they're going on and the system's not ready for them. So zero ready seems to have a lot of potential benefits. And then, of course, that would all translate to also managing peak loads and how to arrange and work with that as well. So just some other thinking around that whole issue to throw in the mix.
Thanks, Sam. And actually, while you're on the line here, Sam, 2 questions for you. I'm going to kind of merge them together. What are the incremental costs for, and I guess this can change per state or locality, but average incremental costs from going to code to Zero Energy Ready? And then how does Zero Energy Ready address the moisture risk with tighter envelopes, specifically with balanced, better ventilation?
Okay, so one is the incremental cost question, which always comes up, and the other is managing the moisture balance in the homes. I think not in the assembly, but sounds like with introducing ventilation and adding humidity to the load of the home. So in the first question, incremental costs, we have done an analysis about when we first started the program 6 years ago, and just recently Rocky Mountain Institute did an independent analysis on the cost of Zero Energy Ready home on their own. And what was surprising, we almost came up with not identical, but incredibly close numbers on the incremental costs. And it ranges roughly compared to the 2012 code, you're looking at somewhere in the order of $4,000 to $8,000, more, which is roughly $20 to $40 on a mortgage increase to go from a 2012 IECC to Zero Energy Ready Home. So the big story there, of course, that we talk about endlessly is that $20 to $40 a month is easily offset by the energy savings on the utility bill. And so that's one thing. But the bigger news is that we find those are just cost calculations that are not considering the learning curve impacts builders achieve when they learn to do this more and more cost effectively. And so we find a growing number of builders are giving direct feedback to us that achieving the program certification is a very modest or sometimes no additional cost. There's these cost credits and cost debits that come into play. And so the builders at the front of the pack are getting some incredible experience learning how to do Zero Energy Ready Home, at least, with very competitive pricing, and are very confident in their position in the marketplace when they add this to their homes. Now, in terms of managing moisture, there are challenges throwing in humid climates with ventilation, additional humidity, and so that would be part and parcel of any program that's talking here today. So the way we address that challenge is we require for humid climates that the builder has to have either a dedicated whole house dehumidification strategy, or they have to use an air conditioning system that can also manage provide latent load control as well. So there are various systems out there where they can throttle down and basically function essentially as a dehumidifier. And if you don't use those systems, then you're coming in with a dedicated dehumidifier. But you do have to manage the humidity loads regardless of almost any program, even in a code home. So that's what how we address that.
Yeah, Lisa, and I know WUFI is specifically designed to assist with those moisture and humidity issues too, correct?
Correct. Specifically in the building envelope. WUFI Plus, built into WUFI Passive, can assess the moisture migration through building envelopes, which is something we do with all PHIUS certified projects. We make sure they pass that analysis or meet prescriptive requirements for building envelope. But Sam's talking about indoor moisture, which we also have the requirements he just mentioned built into the PHIUS certification.
Right.
Yeah.
Thank you. And then, another sort of questioning that kind of gets thrown out sometimes is about geothermal energy and how these programs treat that as renewable offsets. And so, I will just say, and maybe if any of you have a different approach within your program to treating geothermal, but I just want to be clear that there are two sources of geothermal. One is the actual renewable energy source, which is typically on a large utility scale, deep 1,000-feet wells into the earth. And when you're talking about heating and cooling a building, what you're really talking about is ground source heat pumps, which is just at the end of the day an energy efficiency strategy and is not counting towards any of the renewable energy, but eating away at what you would need if you were to use it. So so that question came out. I just want to make sure that that's clear. We have to kind of clear that up a lot. But if anyone else has anything to add to that, please chime in.
Yeah, that's right.
I would just throw in. Oh, go ahead.
No, please go ahead.
Oh, okay. I would just throw in. First of all, usually the power plants are using geothermal hot water sources as a heat source for running generators, and they over time, as the quality of the heat depletes, then they run out of the resource. So it's just using the heat stored under the earth. In contrast, with a geothermal system used for space conditioning, essentially you have an electric consumption, and it would be no different as if you use a conventional compressor-driven air conditioning or any other option. You have to just figure what's your net consumption, and that imposes a carbon burden or whatever you want to assume. So I don't see it. I don't see it as a difficult question. It's power plants. It's obvious. It's just pulling a heat resource under the ground to power generators. And homes, it's just a way to reduce the net electrical use for space conditioning. And whatever you're left with is what you have to offset.
Thanks. Lisa, this is a question specifically for you. For PHIUS, air tightness is the envelope square footage measurement at the exterior or the interior surface of the exterior walls?
It's at the exterior surface of the exterior wall.
Okay, thank you. And then, well, I guess another question for you too is that does the PHIUS 2018 program change space condition targets based on the climate zone?
Yeah, it's actually a specific climate location. So there's roughly 1,000 TMY3 climate data points or data locations that we have specific targets for. So you'll have your climate location, and then it also changes or scales based on building size and occupant density.
And then, you know, for incorporating renewables and or the off-site renewables into WUFI, is that when you're sort of running that model, is that, I mean, it kind of just, does it tell you, okay, here's what you need to, you know, you would have to add to site versus off-site, and you can put that in there so you're kind of, you know, aware of that before you build in your planning package, or is there any more complexity than that?
No, there's really no more complexity. You run the model as usual without any renewable energy, and then you see how much the building will consume, and then you know you need that amount of renewable energy to offset that. So then you can add that piecemeal into the model if you have multiple sources, and then it'll eventually get to zero as your final result, as your net source energy result, and that's how you know you've achieved net source zero.
Mm-hmm. Now, you had mentioned that when you're doing that, I guess for better lack of a term, the cost-benefit analysis piece, that solar is not incorporated into that. Is that correct?
It was incorporated, but it was given an inflated cost, essentially, so that it didn't compete at the same level as conservation measures. So it wasn't really incorporated, but it was and wasn't. It didn't influence the results. I guess I'll say that.
Well, I guess while I have you on the line, I mean, sometimes we've seen in the modeling game and world, you know, where there's a very clear, you know, trade-off of extra solar versus just more lower U value on a window. And just depending on all sorts of subjectivity, sometimes, you know, there's just thousands to be saved using the solar instead of that window. So what do you say if something like that were to occur?
Yeah, so that's why we have the space conditioning targets set up. So once you hit those targets, we say, okay, you've hit the optimal point, and then if you'd like to use solar for the rest of your conservation, or not conservation, the rest of your method to meet the source energy target, that's fine. But we keep these space conditioning targets aligned, specifically this window conundrum, that ensures better comfort, ensures better resilience of the building, lowers your load. We got off that peak shaving thing. It's additive effects when you're meeting these lower loads that we value, which is why these space conditioning targets are inherent to it. Once you meet those, you can do whatever combination of efficiency measures you want to meet the net source energy target.
And the space conditioning target's not prescriptive in that you can use different conservation strategies to get there. Is that correct?
Yeah, exactly. It's all in an energy model. So you put your building in, you can trade off anywhere you want in terms of passive measures to meet these specific space conditioning targets. But these, like PV does not affect your annual heat demand or your peak loads for heating. Like that's not affected by photovoltaics or even heating equipment efficiencies. It's all affected by passive measures.
Andrew, is there a scale jumping, I don't know if you still call it that, or offset that can be utilized within the net zero or the zero energy certification program for ILFI?
Yeah, the zero. Well, so I'll first note that zero carbon you can go directly off site. So we permit that, and that's certainly that program is targeted to allow kind of larger scale projects kind of from the get-go. With regards to zero energy, we do have an offsite exception, but it's pretty narrowly defined to really high intensity projects or projects that have no basically ability to install renewables because they're a tenant or something to that effect. So then they can go off site. But the types of projects that are utilizing that off-site pathway are usually like things like high density like laboratories, hospitals, things that really isn't feasible to do on site. The other, you mentioned scale jumping. That's typically utilized for zero energy when you're in a campus setting. So if you say have a building is shaded by another building or by trees or something like that, we allow you to go to an adjacent roof that is not shaded, but really only if there's that physical restriction where your right to sun has been taken away.
Well, you say campus setting, but I mean, I can think of millions of homes that are just inherently shaded and they're not going to remove their trees. I mean, can they be allowed into this as well?
Yeah, well, so it is worth noting that, any solar is allowed on the project boundary. So you could certainly do ground mount, you could do a shed that's kind of remote from the project as long as it's kind of within that boundary. So, we would certainly have provisions for that sort of thing if there's a more optimal place on the site.
Okay, great, thanks.
Yeah.
So here's another question that we're starting to get more, and Lisa, maybe this might be more specific to you, but and Sam, you as well, but the question really is about sort of this idea that as the climate emergency progresses, there's no doubt that things are going to get more extreme before they get better. Therefore, maybe adding heating degree days or maybe adding cooling degree days and maybe heating degree days potentially. So things could get more extreme. And so what might be net zero today may not be very soon because of this, just the increased demand. So are there plans for moving targets to sort of keep up with the changing extremes in your program, Lisa, or quite frankly, Andrew or anybody?
Yeah, so I'll go first. It's something we've considered, certifying projects to future climate data, not necessarily just like, the past 10 years, but actually climate data that can project out to 2050, 2100. It's not something we're doing right now. We have done resilience testing, and with that, we have used some future climate data. I guess one of the good things is when you are building a really nice envelope, a few more heating degree days, a little bit more of a peak isn't going to hit you quite as hard as it would with the typical building. So they are kind of built or designed with resilience in mind, in that way at least, in passive survivability aspect. But right now there's no roadmap for including future, but we hope to.
And this is Andrew. I'll note that, I think this is part of the reason why we tend to shy away from prescriptive requirements, because they, for like envelope values or other things like this, because they're all based on assumptions of a static model, a static climate model, a static assessment of whether something is capable. So, I think with our teams that are given the outcome as the target, the outcome of zero energy, we've seen projects really take very creative ways to look at that. Certainly most projects put in a certain safety factor when they're sizing their solar to, because they know that even the energy models they're using to predict are not going to be adequate to understand what's going to happen with the weather or the users of any given year. So some teams have kind of done a sensitivity study in that design phase to look at, what are the things that would really affect energy use, such as weather and occupancy loads. And I'll certainly echo Lisa's comments that, having a good passive design essentially insulates you from that risk of future climate changes or temperature changes. So, some of our teams have looked at kind of the sensitivity of increased, heating or cooling degrees. But again, as Lisa mentioned, it's with good passive design, it's not as significant. It's certainly not as significant as variance in user behavior. So, and that's a different, you can have a conversation with your users. You can't have a conversation with the weather, but that's the opportunity. Is really if you can do good communication from the design team to the user and operator team, you can insulate yourself from a lot of those future variances.
Sam, did you have anything to add to that?
Our specifications are always ramping up for us as well. Looking forward, we have changes, but it's not so much in terms of where climate's going to take things. It's so hard to predict. It's mostly where new innovations provide really important opportunities to achieve further savings. And there's always this other kind of view to the future where, as I mentioned during the presentation, that the state energy codes may put us out of jobs. For instance, I don't know how important Zero Energy Ready Home will continue to be in California as their Zero Energy Code continues to be enforced. Right now, I see a value because we bring those performance-based elements that might be missing from their code, and there might be some other value added. But very quickly, as the codes move up only a few more incremental steps, you have to really weigh what is the purpose of the programs and where can you make the best investments. But clearly, we have a whole array of new direction that's opportunities to be more rigorous, and that will address the challenges in the future.
All right. Well, we're a little bit over our time, so I really want to thank everyone for sticking around and thank you all for the conversation. And just real quick before we wrap up, I'm just going to have everyone go through and tell me where people can contact you or learn more if they like. And Sam, I'll start with you.
As I said, the website's the best place to start and get more information about our program. I particularly encourage people to go take the tour of Zero. It's just a great way to pick any location of interest and just see how impressively the housing industry leaders who are stepping up are effectively doing programs like Zero Energy Ready Home. There's lots of other great information, but it's a great place to start and find builder partners and 24/7 webinars and training and resources. So do take advantage of that.
Great. And Lisa?
Yep. So also the PHIUS website, that's just phius.org. We also have educational webinars every month. We have an annual conference coming up this December in Washington, D.C. And our website has a lot of case studies and different example projects out there. And then you can reach me at certification@passivehouse.us.
Great. And Andrew?
Yeah, certainly our website's a good starting place, living-future.org. You can see case studies. We have education modules as well, and a number of events like our annual conference, our Living Future conference in the Pacific Northwest. That's usually in the first week of May. But actually, the best place that I found as a practitioner before I joined the Institute was to talk to real people in my community that did it. So we host volunteer groups called collaboratives that are in most of the regions of the United States and throughout the world, really. So if you go to living-future.org/network, You can get connected to other ambassadors, other folks that have done zero energy, that have done living buildings, and can give you that kind of real world experience.
Great, and since Liz had to go, I'll speak for USGBC. You can email them at netzero@usgbc.org, and if you go to their website, you can find LEED Zero there as well. So again, just a huge thanks to everyone for joining us. This was great, and have a great rest of your week, everybody, and take care.